Bridges play a vital role in transportation networks, yet they are constantly subjected to stress and weight loads that can cause structural deterioration over time. So, our model is a smart bridge weight monitoring system that utilizes IoT technology to measure the applied weight using a load cell with HX711 amplifier and detect vibrations using an MPU 6050 accelerometer. Monitoring the weight and vibrations of a bridge in real time helps ensure safety and prevent catastrophic failure.
So, the objective of our project is to design a system that continuously monitors the load and the vibrations on the bridge by sending real-time data to cloud for storage and analysis.
There are four components that have been used in the bridge. The first one is the node MCU, which is the main control unit that processes the sensor data and transmit it over the internet. Second one is an HX711 load cell amplifier, which converts the analog signal from the load cell into the digital readable signal. Third one is the load cell, which measure the force applied on the bridge. The one which we have used here can measure up to 5 kg. And the fourth one is an MPU 6050 sensor, which detects the vibrations and tilt on the bridge. Software which we have used are Arduino IDE for programming the microcontroller, HX711 and Adafruit libraries for sensor interfacing, and a Wi-Fi library to connect the microcontroller to the Wi-Fi network.
So this is the prototype of our smart bridge. This here is an MPU 6050 module. This generates an acceleration or vibration caused in the bridge. This is an Arduino ESP8266 board. This converts the electrical or digital signals and prints the value in the screen. Here this is an 5 kg load cell. This converts mechanical force to electrical signals. This is an HX711 module which converts or amplifies the electrical signals to digital signals and sends it into the Arduino board. Here the working is very simple. So when a car passes through the bridge, the module or the circuit measures the load and the vibration caused on the bridge.
Now I will be talking about the applications of this bridge. The first application is that the bridge structural health monitoring, used to continuously monitor load distribution and vibrations on the bridges. It helps to detect early signs of natural weakness, fatigue, or damage. The civil infrastructure safety. It is applicable in flyovers, footbridges, and railway bridges and elevated highways for real-time health assessment. It prevents accidents by alerting maintenance teams before structural failure. Sma- For the implementation of a smart city, it can be integrated into a smart city network to automatically collect and send bridge data to centralized dashboard for analysis. Used in engineering labs to study the behavior of bridge materials and designs under varying loads and dynamic conditions. Industrial weight measurement system. Its modified versions can be used in industrial applications like weight platforms, silos, and conveyors where load and vibration analysis are needed. It is also used in the disaster management and post-earthquake assessment. It provides quick feedback on whether bridge structures are safe for use after earthquakes or other natural calamities.
Now moving on to the main advantages of a system. First, it gives real-time data monitoring. The ESP8266 sends weight and vibration data straight to the cloud so you can check everything remotely. Next, it's low cost and scalable. Since parts like the HX711 and MPU 6050 are cheap and easy to get. It's also compact and portable, so you can use it anywhere for testing or permanent setups. Another plus is energy efficiency. The ESP8266 uses very little power, which is great for long-term use. And finally, it supports data logging, so we can track performance and predict maintenance over time. Now for the disadvantages. First, the sensors need frequent calibration and small changes in temperature can affect readings. The ESP8266 has also a limited Wi-Fi range, which can be a problem in remote areas. Then there are power supply issues. It needs a steady source, otherwise the battery life is limited. It's also vulnerable to the environment like dust or moisture. The ESP8266 has limited processing power, so heavy data work must be done on the cloud. And finally, noise or vibrations can cause false alarms if not filtered properly. So overall, the system is affordable and efficient, but it still needs better calibration, power, and protection for long-term use. Thank you.